Now, in hypothesis testing, you can make errors here. So let's examine some of these errors. So there's two outcomes here to a hypothesis test. Either you can reject the null hypothesis, so accept the alternative, or you fail to reject the null. In other words, you accept the null as being true. So there's not enough evidence to reject it. So then your null hypothesis could be either true or false. So if you accept the null when it's actually true, that's called a type A correct decision. Probability is 1 minus alpha. Now when you reject the null hypothesis when it's really true, that is a type 1 error. That's got probability alpha. When you accept the null, in this column, null is false, so you accept the null when the null is false, that's a type 2 error, has probability beta. And then when you reject the null when it's false, that's a correct decision, called type B correct, probability 1 minus beta. So that alpha is the probability of a type 1 error. It's also called the significance level of the hypothesis test. So here's an analogy to help us understand these errors. So in the judicial system, your null hypothesis is that you're innocent. You're innocent until proven guilty. So your alternative is that the person is guilty. So a type 1 error is when you reject H0 when it's really true. So you conclude that a person's guilty when they're really innocent. So, and we don't want to do that because we could end up imprisoning an innocent person. Type 2 error is when you accept H0 when it's really false. So there we could accept H0. We're going to conclude that the person's innocent, but that's really false, so they're really guilty. So we don't want to do that either. Let a guilty person go free. So there's consequences of these errors. So let's formulate some errors and talk about their consequences. So for our first example, in example 1, we looked at a medication for blood sugar here. The null was mean equals 6.5. The alternative was less than 6.5. So a type 1 error, you reject H0 when it's really true. So you reject that the mean is 6.5. You conclude here, so type 1 error, you conclude that mu is less than 6.5 when mu equals 6.5 is the one that's true. So in other words, you conclude that the drug works when it really doesn't. So a consequence here would be that you might approve a useless drug. And actually, it might be worse than that because most drugs have significant side effects, and so you approve a drug that's going to give side effects but not do any good. Type 2 error, you accept H0 when it's really false. So you're going to conclude that the mean is 6.5 when it's really less than. So you conclude mu equals 6.5 when mu less than 6.5 is true. So essentially, you're concluding the drug doesn't work when it really does. So consequence is that you don't approve a useful drug. So people could get benefit from it, but it doesn't get approved because there was an error in the hypothesis test. And then the texting with driving, our null is that the proportion's 24%. The alternative is that it's less than 24. So that means that the program decreases texting while driving. So a type 1 error, again, reject H0 when it's true. So if you reject H0, you're going to conclude that P is less than 24. So conclude P less than 0.24 when really P equals 0.24 is true. So in other words, you're concluding the program works when it really doesn't. So a consequence would be here that you run a worthless program. So you spend the money implementing this program, and it really is not helping people. Type 2 error, you accept H0 when it's false. So you're going to conclude that H0 is true. So you're going to conclude that the proportion is still 24%, when in fact, P less than 0.24 is true. So in other words, you're going to conclude the program is not working when it really is. So what are you going to do? Well, you're not going to implement that program that could actually work. So you don't run a program that works. So hypothesis testing can have errors, and the errors have consequences. We need to be aware of that. Some of these we can control directly. Others are a little tougher.